Hey guys, welcome back to another video. We're going into a new section today. We're going to be talking about properties of rational exponents and radicals, and I'm going to show you using some properties how we can simplify different expressions. Here are all the rules, and I'm going to demonstrate those by solving some problems. But if you do want to look at them, these are all of our rules that we're going to be using for powers. And then these are the rules we're going to be using for radicals. All right, so let's jump right into it. Let's look at this first one. So anytime you have the same base multiplied by each other, so like 7 times 7, even though the radicals are different, so anytime you have the same base and different radicals, you can add the two radicals together. And that's this first property right here. That's what that's showing, the product of powers. So we could rewrite this. We could kind of simplify this as 7. And then 1/4 plus 1/2 would be 3/4. So we can simplify this as 7 to the 3/4 power. Over here with this one, notice that we don't have the same base, so we can't use the product of powers. Another thing we could look at is, do we have the same exponent? Because if we do have the same exponent, then we could use this property right here to combine the bases. But we don't have the same exponent. And then we're taking this whole thing and raising it to another power. Anytime you take a power and raise it to a power, that's called the power of a power, and you multiply the two powers together. So if we do this here, we can take the 1/2 and multiply by 2. 1/2 times 2 is 1. So we'll have 6 to the 1th power, which is just 6. And then 1/3 times 2 is 2/3. So we'll have 6 times 4 to the 2/3 power. Okay, so 6 times 4 to the 2/3 power. Honestly, I feel like that's about as simple as you can get. 6 times 4 to the 2/3 power, because we still don't have the same exponent or the same base. That's what you're kind of looking for, same exponents or same bases. Actually, could we, let's see, hold on, I have a theory here. No, never mind. Okay, false alarm. All right, let's keep going. So with this one down here, notice we have the same exponent, but different bases. So anytime we have that where we have the same exponent, we can combine the two bases by multiplying them. So we can rewrite this as 4 times 3 is 12 to the 5th power. And then this whole thing is raised to the negative 1/5 power. 5 times, and then we can multiply our exponents. So 5 times negative 1/5 is negative 1. So we have 12 to the negative 1 power. And if we look up here, a negative exponent, anytime you have a negative exponent, we can rewrite it as 1 over that, number. So it kind of inverts it. So we can rewrite 12 to the negative 1 as 1 over 12 to the 1, which is just 1 over 12. Okay, let's look at this problem right here. So we have 5 over 5 to the 1/3, which is the same thing as 5 to the 1 over 5 to the 1/3. Notice we have the same base, 5 and 5. So we can, anytime we have that, we can subtract the two exponents. That's this rule right here, quotient of powers. Quotient of powers. Anytime you have the same base but different exponents, you can subtract those exponents. So 1 minus 1/3 is 2/3, so we can rewrite this as 5 to the 2/3 power. All right. Let's move on to some other ones. So here we have, again, the same kind of base here. Or I'm sorry, not the same base, but the same power. So we can combine the bases by multiplying them here. So 12 times 18 is 216. So we can rewrite this as the cube root of 216. And I have a theory about this one as well. Yeah, the cube root of 216 comes out real nicely as just 6. 6 times 6 times 6 is 216. So again, guys, you can combine the bases. If the exponents are the same, then you can combine those bases by multiplying them there. I guess not really combine, but you know what I mean. You can multiply the bases to put it together. Same thing right here. Since we have the same exponent or the same radical, we can divide the two bases. So 80 divided by 5 is, let's see, is that 16? So we'll have the fourth root of 16, which is that 2? Yes. Just comes out real nicely as 2. And you have to remember, anytime you have a even, this goes back to the last video, anytime you have an even number right here, you got to put a plus or minus. All right, so it could be plus or minus 2. Plus or minus 2. Because 2 times 2 times 2 times 2 is 16, but also negative 2 times negative 2 times negative 2 times negative 2 is also 16. All right, let's take a look at this one. So cube root of 135. We can't really do anything with that the way it is, but if we rewrite it as 135 divided by 5 is 27. So we could rewrite this as the cube root of 5 times the cube root of 27, which we can take the cube root of 27. Cube root of 27 is 3. 3 times 3 times 3 is 27. So we could rewrite this as cube root of 5 times 3, or switching places, we could just do 3 times the cube root of 5. So 3 times cube root of 5. With this part B up here, notice they have the same radical. So we can divide these two. So we'll have 7 over 8, the fifth root of 7 over 8. And I don't think that we can make that any simpler. We'll go ahead and try to, but I don't think it's going to work. Yeah, no. So I think that's about as simple as it gets right there. Okay. With this one, a lot of times mathematicians don't like radicals to be in the denominator. Honestly, it's probably not a huge deal, but we can go ahead and simplify this to where the radical is not in the denominator. And the way we need to do that is we need to multiply by something to get rid of this radical. So one thing we can always do is multiply by the difference, and then we'll have the sum and difference rule. So we could take 1 over 5 plus square root of 3 and multiply both the top and bottom by the same thing. So we're going to multiply by 5 minus square root of 3 over 5 minus square root of 3. Again, if you multiply by sum and difference, then you get a nice pattern here. So 1 times this is just 5 minus square root of 3 on top. And then on bottom, 5 times 5 is 25. Square root of 3 times negative square root of 3 is -3, right? And then because we did sum and difference, the other terms cancel out. We'll have 5 square root of 3 and -5 times square root of 3. So those cancel. So 25 minus 3 is 22. We can just replace this with a 22 down here. And there we go. This would be in simplest form with the radical in the numerator. All right, last problems we're going to look at here. We can combine some terms. So notice if we have the same exact radical on both terms, we can combine those terms. So we have 1/4 root of 10 and 7/4 roots of 10. So we can combine them to where it's just 8/4 roots of 10. Same thing here. We have the same exponents, 8 to the 1/5, 8 to the 1/5. So we can combine them. 2 plus 10 is 12. 8 to the 1/5. So that's kind of the main idea there. And then finally, this last one, we don't have the same roots yet, but there's a little trick here because we can rewrite this one as cubed root of 2 times the cubed root of 27. Because 2 times 27 is 54. So we can split that using that rule. Let's go back up and look at it. This rule right here, product property. So we could take something that's together, like 54, and split it into 2 and 27. Okay, and then minus our cube root of 2. The cool thing about this is we can take the cube root of 27. Cube root of 27 is 3. So we're going to have 3 cube root of 2 minus cube root of 2. And we can see now we have the exact same radicals here. So we have 3 minus 1, which is just 2 cube roots of 2. And that is our simplest form. So with these, it's just really using these rules up at the top again to manipulate these expressions to try to simplify them and just make them as short and simple as possible. Anyway, guys, I hope you enjoyed the video. If you have any questions, let me know, and I'll see you next time.